Thinking Aloud. Conversations on the leading edge of knowledge and discovery with psychologist Jeffrey Mishlove.
Hello and welcome. I'm Jeffrey Mishlove. Our topic today is postmortem survival and the physical universe. My guest is Ruth Kastner, who is a philosopher specializing in the interpretation of quantum physics. She is the author of Understanding Our Unseen Reality, Solving Quantum Riddles, Adventures in Quantumland, Exploring Our Unseen Reality, as well as the Transactional Interpretation of Quantum Mechanics, the Reality of Possibility. And now I'll switch over to the internet video. Welcome, Ruth. It's a pleasure to be with you once again.
Thank you, Jeffrey. It's a pleasure to be here.
We're going to be talking about a topic that's a little bit far afield from the normal work that you do in quantum physics and philosophy. We're going to look at postmortem survival and how it might fit into various interpretations of physical theory. I know that when we had our initial conversation about this, I brought up the letter that Einstein had written to the widow of his best friend, Michele Besso, who I think is maybe one of the few people who he credits helped him in some of his major discoveries like special relativity and so on. But Besso died about a month or two before Einstein died, and in his letter to Besso's widow, he referred to the idea. He was trying to console her, and he said, few people understand, like your husband and I, because we are true believers in physics, and we know that the distinction between past, present, and future is nothing more than a tenaciously stubborn illusion. And that seemed to be implying some form of postmortem survival. And I thought that would be a good starting point for our conversation.
Okay. And of course, I'm a great admirer of Einstein. I do think in this case he fell victim to, I'm going to dispute it. I'm going to dispute the notion that physics demands this sort of eternalist ontology meaning what is the nature of reality, what really exists, and so on. It was a very predominant reaction to relativity during Einstein's time. For various reasons that are somewhat technical, the physicists of that era and even today have come to the conclusion that relativity requires this sort of all at once picture. And if you come to that conclusion, then according to this picture, all events, space-time is sort of a block of events, and it's just, they're all laid out from the Big Bang or whenever it all began to the very end of whatever exists, and that time is, in other words, time is sort of spatialized. It's viewed as just another parameter of the extent of where events are located. And this really isn't necessary. And the reasons that it's not necessary, I do go into in some detail in my books. But given that Einstein felt this way, and it's a prevailing ontology that I think does get us into trouble if we do take it very seriously. You can kind of see how he was thinking, well, in this eternalist picture, it's very, very much like Parmenides, the Greek philosopher Parmenides, who had this sort of eternalist notion of the universe. And it could perhaps give some comfort to someone who wants to think of their loved one as identifying with him with these events that exist in space-time in some eternal sense. So perhaps, he felt, well, that's some consolation I can offer. I think we can do better than that, but that's, my initial impression of that idea.
What Einstein was referring to today is people think of it as the block universe, don't they? And I'm pretty sure the notion is that this is completely determined. Everything is deterministic. There's no room for free will or even true randomness, I imagine.
Yeah, that's correct. The idea, if you sort of take this block world idea seriously, then that means for any of us at any particular time, we look at our watch and we go, okay, it's 4:15 p.m. Eastern Standard Time here. Tomorrow, whatever's going to happen to me, whatever I'm going to do, is in the block world. It exists as an event with probability 1. Meaning that no other event is possible for the future. So in a sense, that imposes an idea of fate on you. And the strange thing is that a lot of people profess this block world picture, and yet they still want to maintain the idea that they have free will in some sense. So that gets us into very, convoluted and sophisticated arguments about, how are we going to define free will so that even though whatever I do tomorrow is in the block world and cannot be avoided, somehow I still have freedom to choose it. So there are people who very, very seriously argue that, yeah, I can do that. Then there are other people who say, no, it's a block world. I'm going to, if they're going to buy into the block world, then they say, okay, well, I don't have free will and that's okay. So they usually say that I'm okay with that. So this is the two reactions that you get from people who espouse this block world picture.
It's still held by many people in the field of physics today, in spite of all of the findings of quantum mechanics, which seem to be incompatible with relativity.
The way that a lot of people deal with these problems in quantum theory is they say, okay, well, in a sense, maybe determinism might have to fall away, although you can keep determinism with hidden variables. There are many different kinds of models, but there are ways that you can make a model or give an interpretation in quantum theory that preserves the idea that all events exist in a block world. It could be that there are discontinuities, so that if someone says, okay, well, it's not strictly speaking, it's not deterministic, then they'll have things called indeterministic block world models, where there are just these brute force discontinuities, and one event follows another that seems to not follow from any deterministic law, but it just happens. And so the bottom line with these interpretations is they have to take all measurement results as given. They have to assume, whatever measurement anyone does in the future, has an outcome. It may be that it doesn't arise according to a deterministic law, but it exists in the block world. That, a year from now when, Professor X does his spin experiment on that electron in that lab in Brookhaven, the result he's going to get exists in the block world. There's nothing anyone can do to change that, right? So there's still, that's called superdeterminism, that some people call that superdeterminism. Everything is just spoken for, cast in concrete, and end of story.
So this is a view that is held by a sizable percentage, maybe even a majority of people today in the field of physics?
I think so. I would say so. Yeah. And of course, I'm in the minority. I think that's probably wrong.
We'll be talking about your interpretation of quantum physics as well. But before we go there, wouldn't the idea of the block world sort of implies that every moment is eternal, which is an idea you find in the writings of mystics?
Every moment is eternal. So, that's a wonderful thought. And I would say that actually applies more to a becoming model in the sense that, we've talked about before in our other conversations, and we may touch on today. When it comes to the block world, you can't even really define a moment in a sense. That's one of the, basically it's a bunch of events where event simply means a particular occurrence. or I guess they would also say a hunk of matter. A hunk of matter is at point X at time T, but such descriptions aren't really fully correct because they're all relative to a particular inertial frame and so on. So they aren't invariant descriptions. But you'd have to say that all events are eternal in a sense, and you could say that. It's an eternalist view. So in the sense of, what is a moment? I'm not sure. That's one of the challenges with the block world, because that's arguably a temporal sort of notion, a moment, So it certainly does have the eternalist character in terms of all the events are eternal.
I'm also under the impression, from what little I really understand of general relativity, that because time stops, if I'm traveling on a photon at the speed of light and I should happen to have a watch, it wouldn't move. I can travel across the universe and no time would have taken place at all. That does sort of imply an eternalist vision of the physical universe.
Well, it's an eternalist experience for that photon, we might say. That particular photon, we have to consider what's our perspective here. If you're that photon, while you're in existence, you aren't going anywhere. Okay? Your clock doesn't move, and from your standpoint, there's no separation between, say, the atom, or whatever it was that emitted you, and the other atom that absorbed you. There's no, you perceive no separation. So you're not going anywhere. However, from our standpoint, and actually when I say our standpoint, from the standpoint of a system with rest mass, like if you imagine yourself as an atom, you make yourself very small, shrink ourselves down and pretend we're an atom with our own, an atom has its own kind of internal periodicity, which establishes a kind of time axis for it. From its point of view, that photon had a finite lifetime. It did have a finite lifetime. So, we have to consider whose experience are we talking about, whose vantage point are we talking about.
In other words, it's all relative.
Yeah, Einstein was right about that. I mean, you can still say certain things. You can definitely say that given as measured by the atom's clock, that photon had a lifetime of X milliseconds or whatever. So you can say these things, and you could actually make a diagram of it that would show, at least from various inertial frames, the finite lifetime of the photon. So, who knows? If you were a photon, maybe you could go, hey, I'm alive. Oh, I'm dead. Who knows? I mean, we don't know whether the photon would experience a sense of eternity or not. We only know that it's not going to see any lapse of time or spatial separation during its lifetime.
The eternalist view that we've been discussing, the block universe view, is sort of opposed to another perspective, the one that you hold, which I think you call a dynamical view of the universe, as opposed to an eternalist view. Right.
I mean, the model that I've been exploring does have a form of real change and becoming, in the sense that the space-time manifold does grow and change, and it gathers new events. The other aspect of this model, however, is you could say that it has a kind of eternal feature to it, in that space-time construct doesn't just grow out of nothing. It actually grows out of the quantum level, which I think of as a substratum. So I call it the quantum substratum, which actually is comprised of the rest mass systems, things like atoms and the content of matter as we think of it. So it is from these systems that the space-time construct dynamically emerges. But at the level of these systems, you can say they have kind of an internal periodicity, like that atom I just mentioned. But those kinds of internal clocks, if you will, are not features of space-time. They are dynamical processes, but they are going on and in this quantum substratum. So it's a kind of a radical idea in a way because it demands that we think of our whole idea of temporality very differently. We can think actually of this quantum substratum, which is technically outside the space-time manifold. It's the birthplace of space-time events, and it is a dynamical domain, but yet it's not characterized by time as we would measure it for space-time events. So we can't say, there's an event here, an event there, and they're separated by a certain amount of time. We cannot apply those kinds of metrical measures to it. So in that sense, it doesn't have the temporal and spatial aspects of space-time events. Whether you want to call that eternal, I don't know.
In other words, you're postulating some sort of a reality, a very ontologically real reality that we've talked about several times in previous interviews, apart from the four-dimensional space-time matrix of the Einstein-Minkowski universe.
Exactly, right. And in my proposal, and others have proposed this idea too, it's actually getting a little bit more recent attention, the idea that space-time is a manifold that's actually emergent, and that this domain is kind of a domain of possibility, and that's what quantum mechanics is describing. So it's kind of a natural way to interpret quantum theory and say that, quantum theory seems to have all these strange features, the sort of the fuzzy indeterminism, the non-locality, the aspects that seem to be in conflict with the strictures of relativity. It makes sense if this is describing a domain of possibilities that exists at some subtler level that can be actualized into specific space-time events, which are then kind of just the tip of the iceberg. And I represent this by kind of a geode picture. I think that thinking of a geode kind of gives us a nice analogy in that the possibilities are like the fluid that flows around, the mineral-laden fluid that flows through rocks. And then when you have a gap in the rocks, it can sort of crystallize in the interior. And that this crystallization is just a small residue of all of the fluid that's there. And that's really what is the so-called space-time construct. So it's actually a very small part of reality.
Now, in an earlier conversation, you suggested to me that Einstein's vision of how his friend Michele Besso might have survived in a block universe seems rather pale and hollow, meaning, he exists in the past. The past still exists somehow, that the dynamical universe that you are describing has greater possibilities for postmortem survival.
Well, yeah, I sort of thought of, Einstein being the good-hearted soul that he was, wanted to sort of offer some consolation. But when I thought about it, it just seemed very restricted. Okay, well, your husband was just this collection of space-time events, and I sort of feel as though when people talk about when they explore these ideas of survival of death, which we hear a lot about, and we hear a lot of very interesting experiences that people have shared. I'm just one of those, paranormally challenged people. I've never had any kind of, near-death experience or anything like that. But I am interested in these experiences. And I think that we have to take seriously what people are reporting. It occurred to me that, we have to think, well, when we ask ourselves, do we survive death? What are we? What am I saying? Is there something about me that's going to survive death? Clearly, I don't mean my physical body. So right away, we're dealing with an aspect of existence that necessarily must go beyond physicality and matter in the way that physics usually conceptualizes it. So right away, if we even want to entertain these kinds of questions, we kind of have to set aside the Cartesian dead matter idea of ourselves. Because if that's all we are, then, and consciousness is an illusion, as some people like to say. I always wonder how people can say that, have an opinion if consciousness is an illusion. But, if we're going to be just brute force physicalists, then we kind of can't even entertain the question. So it puts us in this area of examining the self. Are there aspects of the self that transcend the physical, understood in that limited way? So that's kind of the starting point as I see it.
I mean, the suggestion would be that in this realm of possibility, the afterlife exists.
If we understand physical in this new way, quantum theory is a physical theory, but clearly I think, and others, think, it may be pointing to this greater reality, to this more subtle aspect of reality that could be possibility, that seems more abstract and transcends this very superficial space-time concrete world of appearance. So if that is what quantum theory might be telling us, that if in fact there is this subtler domain to reality, then it seems to make sense that that would be an area that could support the idea of the purely mental or even a spiritual dimension to life, so that you'd have room given to you, courtesy of an actual physical theory, by which we don't mean dead matter, but a theory arrived at through science. That this theory may be telling us that reality has these subtler aspects. And in this domain, it's conceivable that, if the concrete physical aspect of you falls away, that there's more to you than just that, and that there's a place for that to exist. So it seems to me to open the door for that.
There are a number of theorists who try to look at this in terms of hyperspace, higher dimensions of space, rather than the four-dimensional space-time model. And you see that notion being employed these days in string theory and M theory, all of these exotic attempts to unify the forces of physics. Does your approach, the transactional interpretation, allow for hyperspace?
Well, it does, and understood in a different way. The term hyperspace can mean, basically a space, a physical space that is not the mere 3+1 dimensions of space-time. Those are very specific theories with specific kinds of structures to them. And they are certainly, entertaining the idea that reality is larger than we thought. What I'm doing is I'm taking the kinds of physical spaces that apply to quantum theory, to just standard quantum theory. So this isn't a new theory, along the lines of those ones you've mentioned, but it does deal with quantum theory in the sense that quantum theory requires mathematical spaces that are way bigger than space-time and have a completely different, a richer mathematical character in that they're complex. They involve complex numbers. So we can consider that a kind of a hyperspace, if you will. It's the ordinary quantum mechanical hyperspace, but it's a mathematical structure that is vastly larger than space-time. And it does seem to lend itself to this interpretation as describing possibilities. Because with possibilities, they can't all happen. So you're going to have many more possibilities than you could ever have, actualized in space-time. So then it's natural to think that they would have this much larger, richer character.
Well, and so the idea there being that if this realm of possibility is ontologically real, it has to be somewhere. And if it is somewhere, then even if it's not in our normal space-time matrix, it would still be mathematically describable. And the same thing could be said, therefore, of the Jungian collective unconscious, the Tibetan Bardo planes, where the afterlife supposedly occurs, and all sorts of other imaginary or imaginal or hypothetical realities.
Yes, the Australian Aboriginal dream time. There are countless examples of, certainly in indigenous and religious and spiritual traditions, having these domains of that you could call imaginal. Some people have used that term, and certainly the way I'm interpreting quantum theory, as you said, I interpret this domain as real, in the sense it exists in reality. So the fact that it doesn't exist in space time is really demands of us that we expand our notion, or the usual notion that space time is sort of a container for everything that exists, which has been the default kind of unexamined assumption. So yeah, what I'm saying is, no, we need to examine that more critically and consider the idea that certain aspects of reality are simply not contained in space and time. And there's ample interior experience of these kinds of concepts, even though that wouldn't be admissible in Western scientific thought. Nevertheless, it is Western scientific thought that came up with quantum theory. So certainly it's pointing in that direction, I think.
Yeah, sometimes the theories that we have are pointing to areas that aren't presently admissible for sociological reasons, not logical reasons.
Right. Yes, certainly. And Thomas Kuhn examined this whole phenomenon in terms of paradigm changes and so on, that sometimes science, I believe science really does progress. And I think that it does help us learn about reality. But sometimes we have to reconceptualize our world in order to really be able to make those leaps and see things in a different way and allow for possible ways of understanding that we may not have allowed before.
Now I would like to push some of these ideas a step further, if I may, to the notion that possibly the universe as a whole is conscious or has a purpose, a teleology. And I read a little bit in one of your books where you touch on this briefly in reference to what is called the principle of least action, which some philosophers have interpreted as to mean that there's a teleology in the universe, a purpose. And in your work, when you refer to the idea of the emitting atom and then the receiving atom for a photon, you're talking about something very similar, actually, that some future event, the atom that's going to receive the photon is acting in a way to influence the photon even before it gets there.
Well, yeah, there are a lot of ideas here, and I guess we could just touch on the principle of least action first. That's kind of an interesting. I mean, there's a way to interpret that without assigning any kind of intent or design to it in a purely physical way, in terms of, well, the waves are going to cancel out. They're all going to cancel out except for this one, and then we're all going to get reinforced, and so on. But nevertheless, there's an economy. A beautiful economy to the way that works that seems highly, non-random. It reminds me of Einstein's and Wigner's comments that the amazing thing about nature is that it is intelligible, and that it seems to have these elegant symmetries and these elegant ways of behaving. And the idea of the other aspect you mentioned, where you've got, in my picture, you've got emitters and absorbers that are required both together in order to create a photon, in order to have a transaction. These negotiations and this sort of mutual influencing is actually happening in this quantum substratum. So it's all going on behind the scenes. And we can think of that as kind of the eternal now, is the way I think of it, because again, it's not a part of the space-time construct, but it's there ready to give rise to a space-time, to one or more space-time events. So if you're, one of these emitters and absorbers, they are aware of each other, and it's a kind of a non-local communication because, again, in this pre-space-time realm, the idea of separation isn't defined. So there are different ways of defining closeness, and it has to do with how probable is it that if I'm an emitting excited atom, how probable is it that if I emit this photon, it's going to get to this atom here as opposed to this one here? It has to do with probabilities rather than closeness in the usual sense. But there's this sort of a communication, a mutual influencing, and at one point, an interaction occurs, and one of these competing absorbers will ultimately receive this photon. It's only at that point that you actually get kind of a strand of yarn, if you will, that gets pulled out and creates a new space-time interval. And it's these events that are created. So the systems themselves are still behind the scenes. It's really much like a movie set. It's like actors and the director saying, okay, what are we going to do? I've got this scene. I got a dialogue. Okay, well, I don't like that. I'm going to change that, whatever. And then they film a scene. That's a hunk of space-time. The actors and the directors are not in that. They aren't literally in that hunk of film. They're still ready to do some more. So that's really a nice analogy for this picture. And in that sense, there's not so much the future dictating anything. It's actually an eternal now that's a birthplace of space-time events. And for any given absorber, suppose you're the winning absorber. Oh, look, I got this photon. I'm excited now and I can become an emitter. From your vantage point, this event, this interplay, and this interval establishes the emission event in your past. So if you're that atom, then from your standpoint, the emission occurred in the past relative to you, and then you can define that. But that's only after the fact. It's after this interaction has occurred.
Well, in a sense, you're anthropomorphizing the atoms.
Actually, if I could just, whenever I'm an animator, I get little peanuts and make them talk, So I'm always animating things. That's what I do with my grandson. I should anyway, I won't do it here. So, and you can sort of impute maybe an intention or a perspective to something that it doesn't mean that we're anthropomorphizing. So I think, we could say, maybe animals have intent. Who knows? Maybe an atom has intent. I don't know, but yes, I'm sort of, I'm taking the point of view of an atom just for fun, if you will. But yes, so go ahead and.
Well, there is a deeper philosophical issue here, which is consciousness itself. Where does consciousness reside? Jung postulated this idea of the collective unconscious. It's widely accepted, I think, in psychology today, yet it needs to exist somewhere. And Jung even went further and suggested that the afterlife, the dead, exist within the collective unconscious. So it suggests to me that in this realm of possibility that you're describing, it's not just inanimate potentials, that there's a sense of aliveness about it, and that the fact that you were anthropomorphizing the interactions there seems to me to be more than just a particular dramatic style that you've taken up, but there's something deeper there.
Yeah, I mean the idea that the experiences that people have had and the Jungian theory of the collective unconscious, that there is this sort of body of research and study and experience that does fit in with the idea that there's more to reality than the sort of concrete actual space-time realm. And certainly if we note that the quantum systems are often thought of as abstract, and that's one of the things that bothered Niels Bohr, that he couldn't make these things fit into space-time. So he immediately said, well, they're abstract. It simply means that they're not tangible. by the usual five senses. If you allow for this broader reality, then there's no reason to exclude the sort of subjective side of life, and the idea that, as I spoke of, that these systems are in this subtler quantum substratum and sort of talking to each other. And I'm using this kind of language, this animating language, but we can certainly even look to this domain for an explanation for why one outcome gets actualized as opposed to others. There could be an element of choice there. So this idea of volition and intention and all of these concepts that are excluded from physical theory done in the usual conventional way don't need to be excluded. Obviously, you have to be careful because you can't you cannot quantify these things in the usual way. So you always have to say, okay, well, it's speculative, and it's not going to be part of an official theory. But there's certainly an opening at the level of possibility for these other kinds of aspects to enter. And other people, I think Freeman Dyson once pointed out that you can think of subatomic or atomic quantum systems as having some element of choice and volition and mind. So there have been quite a few scientists who have also entertained that possibility.
Yeah, when I first learned about the principle of least action, it was from my mentor, Arthur M. Young, the inventor of the Bell helicopter. And he at that time, and I've subsequently learned other philosophers, seemed to suggest that it meant that the photon had a measure of intention, a measure of purpose, that it wasn't following the path of least resistance. It was following the path of least action, which suggested it had to know in advance what that path was.
Here's where I think the transactional interpretation really explains that in a much better way, because if you have these kinds of interactions at the quantum level between an emitter and an absorber, then that's actually going to set up the conditions whereby the photon is kind of, in a sense, doing all of that reconnaissance, exploring what's going to be the most economical way for me to do this. And it has different choices usually, depending on your setup, it can have different choices, not just one. But there are, this is a nice way to understand the kind of otherwise seemingly inexplicable, maybe not inexplicable, but it provides a nice, elegant way to understand how the photon is getting the knowledge and the information that it needs to follow this most economical path. And not sort of having the future literally, reaching back into the past, but having this kind of negotiation that takes place.
Before we close our interview, I want to address one other question with you about philosophy and the mind-body problem in philosophy. It seems to me that one of the principles that runs throughout all of philosophy and all of science is Occam's razor, that the simplest theory is always to be preferred if it can explain all the relevant variables. And the philosopher Bernardo Kastrup, who I think you may know, has argued, I think rather effectively, that philosophical idealism, the idea that the entire universe is basically mental in nature, is the simplest theory and therefore should be preferred, because to assume that there's such a thing as an inanimate world out there means that we're postulating something that isn't immediately available to our consciousness. It's something we assume on the basis of sensory experience.
Yes, well, you can definitely make a good Occam's razor argument for idealism, as you've just noted. I mean, there's the other problem, of course, if you're going to be pure materialist, then you have the hard problem of consciousness. If you're dealing with you're assuming matter is inherently non-sentient, you really can't get sentience from that unless you smuggle it in and play little games of wanting to have it both ways. If you do the dualism thing, then you run into Descartes' problem of trying to explain how a mental substance can interact with something that is completely non-mental, and there's no way for them to do that. So it doesn't really work. I mean, the idea of matter, inanimate matter, is just a postulate. It's a metaphysical postulate that I think has given rise to a lot of problems and dead ends. So, I mean, my personal opinion on the matter is, well, it would have to be idealism if, just for rational coherency, consistency reasons. But I would add that, what seems so hard to believe, I think, for people who are more traditional and more materialist, is it sounds, I guess Sam Harris would say, it sounds too woo, right? To say that everything is mental, because mental just seems too subjectivist and it has a lot of bad connotations. So I think that's what we need to look at next is clearly, if given that we're sentient, and no one can tell me I'm not sentient, I mean, I may be wrong, but I know I'm sentient, which is basically what Descartes showed in, his Cogito, that that mental substance shouldn't be taken seriously. It's because people, I think, are minimizing it and thinking that it doesn't have any potency. It doesn't have any ability to manifest and to create. And so what's intriguing is that it could be that, in fact, that's wrong. And that what quantum theory is telling us is that there's this whole supposedly abstract realm that we could think of as mental, and yet it gives rise to all this experience and there's a lot of stuff going on here. There's a lot of action and things are real. And if you run out into traffic, you're going to get hurt. And it's very substantial in that sense. So perhaps we need to re-understand or become reacquainted with what do we mean by mental substance? And does that mean that it's because it's not something defined as something that I can bang on, does that mean it's not strong and have a lot of power? And that's what we need. I think we need to think about that, because maybe we're wrong about that maybe mental substance has a lot more muscle to it than we thought.
Well, I brought that idea up in a conversation with Bernardo, who's probably one of the premier idealist philosophers around today. And he pointed out that this hard stuff that we knock on, that is our conscious experience. The universe feels hard and feels solid because that's our experience of it.
Exactly. And so what we have are phenomena. So we have phenomena. And I mean, I'm a physicist, so I'm very interested in why these phenomena occur, and I want to know what's really going on underneath the phenomena. But the more you study that, the more you find that what's going on underneath the phenomena is by your usual definition abstract. So it's fascinating. It's fascinating. It doesn't mean it's not real. It's definitely very consequential, but. I think it's a paradigm shift in trying to, I think a lot of people are put off by that because they think that when you're saying everything's mental, that you're saying, no, this table doesn't really exist or something. Oh, no, I think this table definitely exists. I think it's just very, very, very different from what we thought, and it may not be made of dead matter, but it's definitely very real and very consequential.
So do you consider yourself an idealist then?
I guess so. I mean, I don't even like to use the term because it's usually defined in such a pejorative way. But so, I mean, I think that we have to make some distinctions. I think there's a big difference between what I would call the physical possibilities that comprise this table and some random thought I might have in my mind. So I think we have to make an important distinction between those, and they have different kinds of reality, and they can be understood in physical terms, by which I mean a physical theory. A specific physical theory will tell me why a thought in my head is less effective and less substantial, perhaps, than this table. So I would want to make very specific, distinctions of that kind. But so there are many different flavors of idealism, and I definitely would reject some of them. But in that limited sense, I mean, in the sense that whatever substance it is that provides for experience, that has to be a fundamental part of the world, because otherwise you're not going to get it.
And given all of these considerations that we're talking about, I think it's fair for me to conclude, and tell me if I'm wrong, that your understanding of the physical world does not rule out the possibility of postmortem survival of human consciousness.
Oh, no, it certainly doesn't rule it out. And again, it depends on, well, what is it, the me that survives? If we are to survive, what is that? It's obviously something subtle, but there's certainly room for it, given that in my proposal, not everything that exists is part of space-time. And in fact, most of it isn't.
Well, Ruth Kastner, once again, this has been a stimulating conversation. Thank you so much for being with me today.
Thank you, Jeffrey. It's been fun. I appreciate it.
And for those of you watching or listening, thank you for being with us.